from your gross anatomy. Me. What's going to be one of the defining features between the rectum? What are some of the things that colon has that rectum doesn't have? What are some of the features that you find in colon that you don't find in rectum? So colon will have things like what? Posture. What? Postration. Posture. What else do we see? The tinea coli. What else do we see? The appendices epiploicae. Alright? So these are some of the features that are going to be there. Why do we get these posture? What's happening? Why do you get these posture forms? They said basically because of the differences between the sizes of what the longitudinal and circular layer. That's what it's just. Some of the books would say that there's a disproportionate size, that the longitudinal layer basically shorter and therefore causing a degree of telescoping and will give rise to these posture. But maybe let's leave that to what your lecturer would have told you. What did your lecturer tell you about it now? Pardon? Now, what do we know about the tinea coli? What are basically the tinea coli? So one of the things that are going to distinguish it is the tinea coli. Now the tinea coli, the way this cut is basically, I'm looking at this slide, and as I go along this slide, what we find is that the tinea coli are 3 longitudinal bands. And they are named. You can name them: the tinea libra, the tinea mesenterica, etc. But don't worry about the names of these tinea. Okay? They are just bands of what? Longitudinal muscle. Where the longitudinal muscle is what? Condensed. Right? They're equidistant roughly to each other. Okay? But this is not to say that there's not longitudinal muscle between the tinea. There's a complete outer longitudinal coat. However, along 3 points, right? Along 3 points, the longitudinal muscle becomes thickened to form the tinea coli. And this is a platinum slide that you're looking at here. This slide is fantastic because there we see the longitudinal coat right here. Very, 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 very attenuated and thin. Very attenuated here. Alright? Very, very, and then suddenly becoming very, very large. So this basically represents one of the tinea. Okay? So one of the tinea would be here. Okay? Now, you can see that, as you know, the peritoneal relations to the ascending colon, the transverse colon, and the descending colon is that in some aspects there will be a serosa, and in other parts now there will be the adventitia. Okay? Matters which surface you're looking at. The anterior surface of the ascending and descending, or anteriorly we find peritoneum, but posteriorly all we're seeing there is adventitia. So when we look at this colon, what do we see? There's the absence of villi. Okay? So one of the conspicuous features of the colon is the absence of villi. Still we get our intestinal glands, and there we see our intestinal glands, and what we're seeing is that there are a lot of goblet cells. Okay? A preponderance of goblet cells. Okay? Lots and lots of goblet cells. Okay? Alright. But this is a lovely slide in terms of showing the tinea coli. Alright? In the rectum now and the vermiform appendix, you're going to get a uniform outer longitudinal muscular coat. Alright? So when you trace the tinea coli to the base of the appendix now, they all come together at the base of the appendix, so that the vermiform appendix will now have a complete uniform outer longitudinal coat. And the same thing occurs with the rectum. The rectal wall has its muscle basically complete outer longitudinal layer. The rectum now is, as we say, going to go into the anal canal. Once you pass through the puborectal sling, you're going to get the inner circular layer thickening to form the sphincter ani externus, and then now we're going to get a sphincter ani externus, which is going to be formed now by skeletal muscle, having a subcutaneous, a superficial, and a deep part. Okay? So this here is a beautiful slide. Look at that. So you see the outer longitudinal layer is really next to nothing, and then now coming to form the tinea. Alright? Alright, now let's look at another slide. Let's just look at this slide. Now I picked up one or two different slides here. Not too sure how this one is going to look. Alright, so what we have done here is stained this colon here, I think, with some Alcyon blue, well, yes. Mason, it's a Mason stain. Alright, and you see the goblet cells looking. I thought I had an Alcyon blue. I think I have an Alcyon blue one here. This one's out. So this is a Mason stain colon right here. Just go. Alright. And there we can see that the intestinal glands are just filled with what? Goblet cells. Alright, so the epithelial lining that's all connective tissue. Alright, and there we can see just masses of what? Goblet cells. Lots and lots of goblet cells. Okay? Look at this here. This is purely nearly all. So this intestinal gland is all, they're just, this pure lining going up and down is just purely of what? Goblet cells. So mucus secretion here is at a max, because now you have passed through, and the fecal mass, basically there's a lot of absorption of water, and for the fecal mass to move, you need to have a lot of goblet cells. Alright. This slide might also show it. Okay. Alright, so this slide is so old, it is quite a historical slide here. Maybe many years ago, stained here with Alcyon blue. So what you're seeing basically, all of this here basically is, see a lot of goblet cells, and the mucus is secreting, the mucus here is staining in blue. Alright? So there you can see all of the goblet cells. Okay, no. So let's look at this. This one may have a good tinea coli on it. Yeah, there. Right there. Alright, so there we see on this particular slide also, this is a very old slide. Oh, this must go back into the 1980s. Alright, so there you see this outer longitudinal layer right here, and then when we trace it along, we suddenly see this outer longitudinal layer becoming massive. Alright, and this basically here is the tinea coli. Alright, we're going to take our last break, and then we're going to get into rectal and anorectal junction. So take a look at your slide.